Hello and welcome back. This is the first video on a series covering chapter 16, conjugated pi systems. In this video I will cover the preparation of conjugate pi systems and what they are. But before I jump into that, I want to preface by saying that these videos are only supplementary to the learning we do in lecture and they should not be treated as a substitute. Thank you. Conjugated pi systems are molecules where we have two alkenes separated by one carbon. A key characteristic of these molecules is that each carbon is sp2 hybridized, whereby all their p orbitals overlap as such. In order to prepare these molecules, we can use halides. In this first example, we can use third butyl in order to add an alkene terminal on the least substituted side. Third butyl, or any bulky base, would achieve that aim, and we're left with this molecule. Third butyl would deprotonate this hydrogen, and the electrons of this hydrogen will go here, kicking out the bromine, thus forming our conjugated pi system. Another example is a dihalide, a vicinal dihalide. In this example, similarly, we can use two equivalents of our bulky base, third butyl, to double deprotonate. So the first deprotonation would happen here, where our base would deprotonate the hydrogen, and the electrons from the hydrogen would go to this carbon-carbon bond, thereby kicking out the bromine, so that we can produce this molecule. Similarly, third butyl, the other equivalent of third butyl, would deprotonate this hydrogen, the electrons going to this carbon-carbon bond, and subsequently kicking out the bromine in order to produce this conjugated pi system.